In this video, I will talk about the transpose of a matrix and a vector. Let me start with the data matrix. I covered the data matrix in a previous video. The data matrix combines a constant term, which is just an all-one vector, and several independent variables. For instance, x1 to xn and z1 to zn. In this case, my dimension I runs from 1 to capital N. Now this could be a cross-sectional data set, but it could be also a time series. It doesn't really matter. Looking at our data matrix, we can talk about the dimensions of a matrix. So we have n rows and 3 columns in this case. Now the transpose is very important in matrix calculations, also in the context of OLS regressions, for instance. To take the transpose, we take our matrix X and apply prime or T. Both is used to indicate the transpose. The transpose switches the columns and the rows. So in this case, the first row becomes our first column. So that means we have 1 x1 z1 followed by 1 x2 z2 and then 1 xn zn. And as you can see, we end up with 3 rows and n columns. So we switch dimensions. In the case of a vector, the same happens. So if we have, say, a vector of a dependent variable, y1, y2, up to yn, this is a column vector, dimension n1. And now if we take a transpose, it becomes a row vector, which means we have, in this case, 1 row and n columns. Now, we will come across a transpose several times when we do some further matrix calculations. I see you in the next one.